Hey. Hello, everyone, and welcome. Colleges in Institute Canada are happy to host today's workshop through the Impact Climate Project with funding from the Government of Canada through the Environmental Damages Fund. To learn more, please go to their website, impactclimate.ca. And so welcome everyone who is joining us from the many different campuses across Turtle Island. My name is Stephanie Fulford. I'm the Sustainability Specialist at RFC Polytech. Um, Red River College Polytechnic campuses are located on the lands of the Anishinaabe, Innuit, Anishinaabe, Dakota, and Dene, and the national homeland of the Red River Métis. We respect the treaties that were made on these territories, and we dedicate ourselves to moving forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. We recognize and honor Treaty 3 territory in Shoal Lake 40 First Nation, the source of Winnipeg's clean drinking water. And in addition, we recognize and honor the treaty territories which provide us with access to electricity we use in both our personal and professional lives. Electricity and energy use is, of course, why we're here today. I had the special privilege last year of seeing our panelists present at the annual ASHE conference in Boston, and so I know that we are in for a rich and thought-provoking session today from a panel of true experts in their field. And because I know they have such valuable information to share, I won't take up any more of your time and we'll skip straight to the introduction. I'm pleased to introduce Ryan McPherson, Chief Sustainability Officer, University at Buffalo, Tonga Pham, Associate Vice President for University Facilities, University at Buffalo, and Jason Deneau, Vice President, Energy and Principal at WENDEL Companies. Thank you for joining us today.
Great. Stephanie, thank you so much for hosting us and having us a part of your community. We are very grateful for that. Jason, if you want to share the deck, we'll see if we can get those up. And before we jump into things, again, we're excited to have this conversation with you. Please feel free to utilize the chat at any point. We will be looking at that as well as any Q&As. And if you have a question during the presentation, by all means, feel free to raise your hand. We'll do our best to call on you. We will have discussion time throughout. But maybe just to get us going here, we'd like to make you, I guess, maybe a few promises. The first thing we're going to do is we're going to try not to bore you to death today. Second thing, we're not going to yell at you or judge you. I can assure you our shortcomings are greater than yours. Third, while my job is to focus specifically on climate change, contrary to popular belief, we're not going to talk about polar bears. And maybe third or fourth here, while Jay and Tonga are, definitely engineers, and we'll get into that today, I've been assured that they're not going to nerd out with you at all and speak tech language. And then finally, I promise you that we are not going to talk about this. And next slide, Jay. We are, though, I think just to take a special moment here and promise you that I guess we'd be remiss if we didn't reinforce how important the relationship is between our two countries. We are a border city here in Buffalo, New York, and our proximity to Canada and all the beautiful things that it has to offer is one of our greatest assets, and why personally I live in Buffalo, one of the things that pulls me most to this city. This is actually a shot of a high school hockey team I coached for years, playing a match outside of Toronto against De La Salle, and it reminds me of this amazing partnership and friendship that our two countries share. So while that may not necessarily be reverberating in political circles these days, I just wanted to, and we just wanted to underline how grateful we are to be with you all. And speaking of which, Tonga, would you like to take it from here?
Absolutely. Thank you, Ryan. Stephanie, thank you so much for the kind introductions earlier. This is just the picture of the three of us with our specific titles, and it's in the deck for you to later reference if you need to. And then I just kind of wanted to go over our learning objectives today and just kind of set the table on what we're hoping to deliver to you as an outcome and things that you might be able to pick up and glean maybe some little treasures that you could utilize on your various campuses as well. So again, I'll just quickly run over everything. So we're hoping to provide you a very holistic understanding of just kind of like some of the technical drivers and some of the transformative change that can occur by implementing a strong energy infrastructure. Understanding the technical approaches for navigating some of these constraints that you might have on your various campuses, whether it be physical, technical, or economical, and we'll get through that. Also appreciating the development of phasing strategy. And I think just being the sector that we are all in, I think phasing is probably our favorite word. At least I know it is mine on the UB campus. And then lastly, just I guess recognizing just, the key like organizational change initiatives that this really is at the end of the day, right? And just ensuring that we have stakeholder engagements and we'll go through with our case study as well.
So I just wanted to tell you a little bit about kind of a little spoiler alert about what the end's going to look like. So by the end of this, what we're hoping to have a little bit here is kind of different advancing climate action. Why? Why do we really care about this, right? Increasing retention of talent, keeping pace with current policies, reinforcing conclusions from researchers in the scientific community that we all are engaged with, building greater resiliency into our universities, and aligning our infrastructure with our university values. We'll talk a little bit about, the alignment of strategic visions over a 25-year period, how to incorporate life cycle cost analysis to align the financials with some of the data and some of the vision that we may have for our universities, how to take on proactive funding strategies and break that traditional funding model that we may have, how to rethink our approach to CapEx and capital expenditures, and how to invest greater capital in the front end of these types of projects. And then ultimately, how to invest in incremental changes over time and not do it all as one lump sum purchase, but understand that these are investments. It's not a project, it's a program that happens over a period of years, if not decades.
Great. So Jay just talked about what we're going to kind of tell you, and the punchline it is. This is kind of how we're going to do it, if you will. First, we're going to talk a little bit about the team itself to advance this decarbonization practice and what that's meant for us and how we've done that. We're then going to spend a little bit of time framing out the why, which may seem self-explanatory, but for us, it's really important in terms of different people have different whys across your campuses and the external partners that you're working with. So we're going to kind of outline some of those from our perspectives. And then Jay's going to dive into what is it that we're really talking about? What do we mean when we talk about thermal energy and the broad kind of look at creating a clean energy master plan this way? We'll have a little pause after that just to kind of catch our breaths. And then we'll come in to look at how this actually looks in practice. So we'll take that information that Jay just kind of laid out, and then we'll use it within the context of the university at Buffalo. And then Tonga will kind of dive into how the institutional change is occurring to increase implementation. This, I think, is kind of one of the most fascinating parts, which is kind of like, okay, you can have all that in the textbook, but then at the end of the day, how do you actually make this happen with the different organizational behaviors that we have on our campuses? And then finally, what are the costs and how will we fund this? So that'll be the layout of our program today. And Jay's going to jump in with talking a little bit about the frame of the team.
So when we talk about the team and who to bring to the table, I love this quote here from Steve Jobs, right? You want to go fast, go alone, but if you want to go far, go together. And it really does start with a collaborative effort. And we've been fortunate enough to be able to have that collaborative effort for a lot of the work we've done at UB. So some of the key stakeholders to think about as you start trying to pull together one of these planning efforts is understanding, basically the CFO, making sure they're at the table, your operations and facility managers who are directly impacted by these type of transformative changes, the sustainability manager who's helping drive the why, drive that objective, and consultants like myself and engineering teams who can come in and help apply our expertise. Not to solve the problem, but to be part of the solution, part of the collective team. there's a philosophy that we like to communicate, and it does start with why, right? So we're talking today and we're communicating this way of starting with that core vision of why do we want to go after this? Why do we want to burden ourselves with these efforts? What are the things that we need to do in order to get to that end goal? And then how are we going to go through and do them? So as we set the table, kind of with the who and setting a little bit of the discussion in the format of what we're talking about, we'd actually like to take your temperature a little bit. We put together a little survey here that we'd welcome your feedback on the different types of 3 different questions that in fact that help influence the presentation. So maybe we can throw the survey up here. Does everybody see the survey?
Yes, I see it. Thanks.
Awesome.
We've just had a bit of a glitch. I wonder if we can just maybe keep it up a little bit longer because a few folks were in the wrong link. So we're just having a bunch of folks join us now, I'm noticing. So it disappeared off the screen very quickly. So if we can bring the survey back, there's a lot of people just joining. There we go. Thanks. So let's just leave it there while folks are joining us. Thank you. And sorry about that.
Go. It looks like people are chiming in here.
Yeah, perfect. And the reason why we're actually doing this and we're trying to get the feedback is it just really helps us set the tone for some of the discussion we're going to have today. There's a lot of data that we're going to go through, and helping know kind of where everybody on this team is coming from helps us tailor some of the responses and the information we're going to share.
Great to see. About 5 more seconds, or maybe about 20 seconds here.
So at this point, maybe give another maybe 5 seconds here, and then we'll end the poll. All right, I think we got most of our participation here. So can we go ahead and end the poll? Perfect. Let's share those results. So you kind of see on the screen, I'm not sure if you guys can see what I'm sharing now. So for the first one, what is your why for advancing climate change, right? Majority of us is to minimize the impact on climate change. A couple people here on policies, students are asking for it, but overall, pretty common theme of really trying to minimize the impact our facilities, our campuses have on climate. What are the strategies you considered? Pretty good mix here between energy conservation, electric-based boiler systems, and a little bit less on geothermal. And then a couple individuals or one individual has not even started looking at some of these type of strategies yet. And then kind of what is the biggest barrier? Funding, right? That dollar value, being able to find the capital to make these things happen. Supportive leadership and resistance to change from facility staff and others. So I think all those things resonate in one way or the other, but I appreciate everyone's feedback. Like I said, this is going to help us influence a little bit of some of the things we're going to dive in and focus on. So with that, as I said, maybe Ryan, I'm going to turn it back over to you to talk a little bit about why.
Yeah, that's great. Thanks, Jay. And of course, we cheated because the real answer is multiple things, right? We forced you to choose one. I know probably some of you, if you were like me, wanted to choose all of them, and they all are in play. I want to just jump in and just again frame out this why for us. There's really 6 kind of key drivers for us, at least here at the University of Buffalo. You can see up on the screen. I'm gonna give a couple proof points on those top three. And the reason this is important is because it has a lot to do with organizational behavior, support from senior leadership, and different people have different pieces that are pushing them in directions. And I think in my role, I need to really be thinking about that and framing that to see how fast and quick we can go. The science for us at the university is one of our top things. And I'm going to use this just as a kind of refresher to, I think Canada knows this well. I'm sure you know this well. But the inherent challenge that we have right now in front of us. These are our geologists up on the Greenland ice shelf. That's Professor Jason Briner. And what they do is they dig down and they pull up these ice core samples or mud core samples. And you can see on the next picture, in the upper middle of that, that is a picture of that ice core sample. And then they plot this over time, right? In this case, 800,000 years. And in the vertical axis, you'll see basically carbon footprint, right? So CO2 concentration. And you'll see the circadian rhythm over the course of those 800,000 years, which represents the ice ages and retreat and recession. And nothing has really pierced that 300 parts per million, of course, until we get towards our modern day era and corresponding to the Industrial Revolution. And that is the rub. That's the infamous hockey stick graph that's been referred to. And we find ourselves in this precarious position, of course, today at above 420 parts per million, way above that magical line that has created that Holocene period for us, or also known as a stable climate. It is not what we have now. Right. So the next picture, thinking about, and Jay, you can just kind of move through these, what that destabilization looks like, whether you're on the West Coast and fires or forest fires. This is actually forest fire smoke from the Canadian wildfires 2 years ago in Manhattan. And then I just want to show you kind of some data on this. Keep an eye on the lower right, red in the right corner, which you can just barely see over time. This is 80 to 90, 91 to 2001, 02 to 12, and then finally 13 to 23. The reason this is important is the #1 natural disaster in terms of death rate are heat waves, especially elderly, and thinking about Buffalo and lots of Canada with old housing stocks and not sufficient air conditioning, right? So this is what is directly linked to that science. And then the other side of this, of course, is the precipitation. And so we see that this is a great, I will say, the Gulf of Mexico graph here showing over the last year how abnormal that was in the fall of 2024. And of course, that had a direct correspondence to the intensity of those hurricanes that then left the following disaster in Tampa Bay, as well as inland 500 miles in North Carolina. So all of these really kind of corresponding to that science, and really what I wanted to just kind of remind us of the intensity that we're dealing with. And I know many of your campuses are as well. The second factor is really about the kind of demand that we're seeing for the recruitment of talent. So both students and also our employees. So that next slide just gives you a reminder of where you are, if I'm going to use these terms, Zs and millennials, because they are our target audience at the university, and I'm sure they are for you as well. And Deloitte does this survey every year. It used to be called the Millennial Survey. It's the Millennial and Z Survey. In the last 5 years, climate change has come in #2 consistently across the board, losing out only to cost of living, which it will always lose out towards, in terms of the kind of top concerns that are on their mind. And the reason this is important is because 72% of students think how a university is working to take climate action is an important factor in deciding where they go to school. We call this our provost slide. This is what really kind of, I think, drives the why for him. Yes, it's the right thing to do, but he really sees this, of course, within this business model. And then the same thing holds true on the workforce side of the equation. It's not just about the recruitment of students, it's about the recruitment of talent. 2019, look at how the workforce looked in terms of generations. And now in 2025, really at the end of this year, 75% of the workforce, right, will be millennials and Zs. And so if you take that data from Deloitte and integrate that in, and this is again important because on the next slide, it parallels what the students are saying, off by 2%, but 70% of those in the workforce, right, are care about what their employer is doing on this, and it is a factor in them deciding where they're going to go to work. And the final area here is the regulatory aspect. We need to stay out of jail, right? In the state of New York and in the nation of Canada, right, we have laws that are in place that are pushing us to decarbonize across the board. This is a mini Green New Deal that we have done here in the state of New York. You can see many of the things up there in terms of no more sales of internal combustible engines by 2030, 2035. The Climate Leadership Community Protection Act, we phased out coal-fired power plants here in the state of New York. And then, even at the federal level, we are still working within the IRA structure and the incentivization. That's a picture of Vice President Harris here on campus rolling out the IRA a year and a half ago. And finally, of course, and I'll close with this, you have many regulatory pieces on the books, not only at the national level, but of course at the local level as well, that are moving you. So really the kind of takeaway here is that different audiences, there are different whys for them, and learning to really, I guess, put messages in digestible formats within those areas of who you are talking to really helps us quite a bit. Jay's going to explain a little bit of a different why here.
So we talk about all those things and we see the momentum there, but why is it so hard for us to break our addiction to fossil fuels? So I'm going to spin this a little bit on more the technical side. Fundamentally, fossil fuels by their nature are stored energy. That investment in energy came hundreds of millions of years ago, but it's stored solar energy that's in the form of oil and natural gas. And what's really important to understand about that oil and natural gas is that it has a very stable and concentrated energy density. And so what you're seeing here is the different forms of common fossil fuels and their energy density in the metric of megajoules per kilogram. That high energy density has allowed us to create mobility from them, right? They're a stable form of energy. We can put them in our vehicles, we can transport them to our sources, and we don't need to use that energy until we want to use that energy. As I mentioned, it's still the idea of stored energy that happened 500 million years ago. And so why is it so important to understand that aspect of stored energy in fossil fuels is when we look and compare it to another type of storage option, which is battery technology. And in this, you can look here and you can see at the bottom the different types of batteries and the energy density that those batteries would have. And what you're going to gain from that is an understanding that fossil fuels are 100 times more energy dense than the best available battery technologies on the market. That right there, that idea of being able to store energy, have that energy available when we want to use it, is so important to our energy infrastructure today. You hear oftentimes the idea of challenges of energy storage and the need for storage of energy on the utility grid. That highlights that. But I do want to leave you with another technology that's emerging. And while we won't be diving too far into the depths of hydrogen technology, this is an emerging technology that has the potential for surpassing fossil fuels. Hydrogen, on its purest form in energy density, actually has 120 megajoules per kilogram, 3 times that of current fossil fuels. So as I just kind of laid out some of the challenges with fossil fuels, I just want to highlight here some of the opportunity that's there in the future. So what I'd like to do now is start to frame the what. Kind of talked about the why we're so invested in this. We're talking about why is it hard to get off of fossil fuels. Now I want to start framing the approach and kind of do a little level setting here. There's a lot of different things that you hear about, and we kind of did in the poll, right? You've heard about geothermal, you've heard about renewables, you've heard about the impact to utilities. You've heard about the financial aspects of these projects, and many of you have talked about that being the biggest challenge you have to going out and achieving them. You've heard about staff changeovers, and some of you have commented on that being a limitation. Heard about technology, disruption to project sites, the existing equipment, and resiliency. All of these paint a tapestry, if you will, of different factors that influence a long-term decarbonization plan. And so what we did at the University of Buffalo and continuing to do is starting to develop a long-term strategy. And what we want to outline here is how that strategy goes together. The strategy itself is kind of all-encompassing and takes a long-term view on campus infrastructure. We like to start with energy efficiency. The stuff that you guys have been doing for years, the LED lighting, the HVAC controls upgrades, the water conservation, the building envelope improvements, all that's great stuff, and it helps reduce the energy usage for your entire campus. The best form of energy is the energy you're not using. So focusing on energy reductions is key to these types of strategies. From there, we start to look at the idea of energy recovery, right? It's not enough to just conserve energy on site. We want to start recovering that energy that we may be using. There may be times where you're doing simultaneous heating and cooling. Is there ways to recover that energy? We look at bringing in alternative fuel transportation systems to our sites, and that has an impact on our energy infrastructure. As we look and evaluate what does the systems in 10, 20, 25, 30 years, more and more it looks less like an existing steam system that we may have had from 100 years ago. Right? We're starting to remove those systems from our campuses. As we evaluate all these different infrastructure items, it's time for us to start looking at different thermal energy sources. And I'm specifically targeting thermal energy sources because this is our biggest source of fossil fuel usage, the things that necessarily heat our campuses. This is where we have to look at sources, alternatives such as geothermal, electric resistance, air source heat pumps, and other types of thermal energy sources to offset what previously was being used from fossil fuels. As we do that, that's going to have an impact on the renewable energy that we need in order to produce the electricity to offset our campuses. That may have an impact on our local utilities and the infrastructure that we have supporting our campuses. As we understand those constraints, we may start having to look at different energy storage strategies. I just talked about lithium-ion batteries in a previous slide, but these could be other options as well. I mentioned hydrogen as a potential storage option. There's also thermal energy storage in the form of fluids such as ice or water. A key aspect to the success of any type of plan is understanding and making sure that the operation and maintenance staff is there that can actually build the skill sets necessary to adapt to the changing technologies. And we're also creating solutions that adapt to them. We're not putting in 100 different compressors into one building expecting no change in the operations of the O&M staff. And then as we progress through these technologies, the reality is things are going to change. Technologies are always going to evolve. We want to create an infrastructure and a system that is open to accepting new technologies over the next 20, 25, 30, 50 years. And so creating this backbone infrastructure system that is able to accept different energy inputs from different sources. All of these different items come together ultimately into forming a carbon neutral energy system. But it all happens over time.
Jay, can I just pause
go ahead.
there one quick second? This was inevitably we get this question of what do you wish that you did differently had you known it at the beginning? I wish I had listened to Jay earlier on and actually absorbed this slide because this is really kind of the key strategy for those of us who are not technical like myself of what's going on in this process and all of the different kind of pieces that really come together. I was just thinking it was in that thermal energy kind of piece, right? But it is a holistic kind of approach that really brings in all of those factors, and they affect everything. So I just wanted to kind of underline that for people. This is the takeaway slide from my perspective of the overall process. Sorry, Jay, go ahead.
No, that's great. And this slide is actually going to help us walk through the story later on as we talk through how we apply this to UV. Another slide we like to use quite often is taking everything I just said and now simplifying it even further. There's three fundamental buckets, if you will, on a campus of how energy is being used. And one influences the other. And it all starts with the load. We define the thermal load, we define the energy load as the buildings, the laboratories, the dorm rooms, the academic facilities, right? At the end of the day, energy is used on campus to serve those loads. And those loads, what they're needing is telling our thermal energy plants what they need. They may need steam, they may need hot water, they may need chilled water, right? They may need cooling or heating from different sources. And at some point, we have plants that kind of sit in this middle area that are transforming energy that's being brought in, electricity or natural gas. These plants exist to transform that into the services necessary to serve the load, right? They're transforming it into the hot water that goes out into the buildings. They're transforming it into the chilled water. And that gives us opportunities, right? When we define it that way, that gets us an opportunity to look at the way we transform energy on our campuses and possibly do it in different ways. As we make those changes to our plants and change the way our plants transform energy on campuses, that subsequently has an inherent impact on the utility. If we can transform those systems and use electric boilers or geothermal heat pumps, we can use we'll use less fossil fuels as a utility. And depending on how we do that, it's going to increase or change the amount of utilities or electric utilities we're going to need. Ultimately, that utility aspect can be generated either on-site through renewables or purchased off-site through our grid system. But those are how those three fundamental components all come together. And with that, I kind of want to double down a little bit here and zoom in on these plants. It was great that many of you kind of commented on geothermal and heat pump systems early on, but you're going to hear me switch now and talk a lot about these strategies, and all of a sudden I'm going to start using this term heat pump over and over and over again. And I kind of wanted to do a little deep dive as to why. So let's say here you have a natural gas boiler today in most of our facilities, right? And simplifying that down a little bit, this boiler is kind of composed of kind of two primary spots. You have the burner and you have the boiler body. And if you wanted to get 1,000 BTUs out of that boiler, you're basically going to put 1,200 BTUs of natural gas into that boiler. About 200 of those BTUs are going to leave as waste through the flue stack. This is an 80% efficient boiler. This is what we see on the market today. This is what's in most of your facilities right now. So 1,000 BTUs I need to provide heat to my building. I'm going to need to bring 1,200 BTUs of natural gas in. Well, let's say we wanted to put an electric boiler in. Well, we can get rid of that burner. We just have the boiler body at that point. And to get that 1,000 BTUs out, well, I only need to actually bring in about 1,050 BTUs coming in. I'm not combusting anything anymore at the source. I only have about 50 BTUs of loss. So electric boilers by their nature are actually more efficient than natural gas boilers. But they're still using about 1,000 BTUs of input energy. So then let's talk about a heat pump. Well, a heat pump is different. A heat pump by its nature transfers energy. So what it's doing is in order to get that 1,000 BTUs out, it's going to go and it's going to absorb 700 BTUs from somewhere. That somewhere could be a chilled water loop. That somewhere could be the ground through a geothermal system. That somewhere could be air. It's going to absorb 700 BTUs of somewhere, and it's going to have a compressor that's being acted upon by electrical utility input energy, about 350 BTUs, to create that 1,000 BTUs out. So it's not generating energy the same way a boiler does. It's actually transferring energy from one area to another. And what's the key thing to understand here is that the input energy from the current boiler is about 1,200 BTUs of energy coming in to get that 1,000 BTUs out. Whereas a heat pump, you're only going to need 350 BTUs of energy coming in order to get that 1,000 BTUs out. If you've ever heard of the term called coefficient of performance, this is what is considered the coefficient of performance. Basically, this allows a heat pump to be able to get more energy from the system out than the amount of electrical input energy coming into it. An incredible advantage when you're trying to electrify your campuses. To complicate, yeah, go ahead, Ryan.
Maybe, Jay, I was just going to pause there to see if anyone had any questions on the heat pump kind of explanation, definition. I know most on this call probably are aware of those things. I found this really helpful in terms of thinking about that, why it is so much more efficient. But we'll just pause to see if anyone has any questions at all. You can either throw them in the chat or raise your hand. Steph, I'm not sure I see everyone, so if you see someone, please call on them if they do. We have time as well at the end of the presentation for other questions, but I just wanted to see if there are any specific ones at this point. And one that did come in, Jace, that I just wanted to get your take on, and I'll take a little bit of a different approach with it, is one on nuclear and on the energy density of nuclear when you were talking about why on the fossil fuels. I won't put you on the spot and say, do you know what the energy density is of nuclear? But anything that you want to talk to on that front, and then be happy for all three of us to also answer the other part of the question of what its role may be.
Yeah, it's a great question. And I don't off the top of my head have the energy density of uranium and plutonium from that perspective. I think it's actually calculated slightly different than kilojoules per kilogram in that same capacity, because I think it's because the pathway for actually absorbing that energy is different. But it's a great question. So I don't actually have that, that answer off the top of my head.
Great. And I guess, and Tonga, feel free to jump in here as well. I'd answer the larger question that you asked. Really, sorry, I think it was Chester who asked this. I'd start it with the way in which President Obama answered the question, which is, this problem is so big and so massive that it's going to be an all-in strategy here. We're going to need to use everything we possibly can. And we know that renewables, even with storage that is coming online, but we know that renewables, most of them are intermittent. And so we've got to think about something that can hold the grid together and really act as that backbone. I think nuclear, from my perspective, has a role in that. There's a lot of, obviously, issues with that. Had you asked me this 3 or 4 years ago, I might have been a little bit, as a sustainability officer, a little bit less embracing of it. I think what we've seen over the last few years, especially with the rise of AI and so much demand, that we're going to need that source to help us. How, why, or not why, but how, and the details on that, I think will be interesting to see. The one other piece that I would add in there is thinking about, we've got some great faculty on our campus who are doing some work within hydrogen and fueling it via nuclear, pink hydrogen as they call it, and thinking about that as part of the solution too. So from a storage perspective or from a hydrogen perspective, which we'll talk about in a little bit. Anything else to add, Jay, Tonga?
No, I think that's good.
No,
Great.
perfect on our side.
Great. Jace, maybe move in. I was just looking at our timing. We might want to move into our other section, and then we can kind of rearrange that piece.
Okay. So as we kind of talk a little bit here, and I kind of set the table, if you will, on heat pumps and how they're incorporating what our strategy is, let's take a second here and we'll talk a little bit about University at Buffalo and how we were able to start applying this to UB. So with that said, maybe Tong, I can throw it over to you, maybe describe University at Buffalo a little bit.
Yeah, absolutely. So I hope you all found what Jason did was beneficial. We often just, we have such a diverse set of, attendees, and we just kind of want to make sure that everybody's on the same page and, has the same type of information and the same lexicon that is being used throughout. So the next part of our presentations are going to be more, I guess, case study approach, if you will. So we'll specifically be looking at University at Buffalo and how WENDEL kind of approached us. And I think this is where a lot of you might be wanting to get into the how on earth did we fund this, or how did you kind of garner that level of engagement from your executives? So first and foremost, I just wanted to talk a little bit about the University at Buffalo, nothing more than to just set the stage and let you know the size of our campus, what we do here, just to kind of give you a bit more context as we kind of break it down of what our journey has looked like here. So the University at Buffalo institution, so research intensive. We're made up of actual 3 campuses, and I know when I joined the team, I was really confused with the term University at Buffalo, when really our South Campus, so we have a downtown in our medical corridor. We have another campus, which we call the South Campus, which is really located in the north part of the city of Buffalo. And then our larger research institution is actually located in Amherst, New York, which we name as North Campus. So 3 campuses, jumping down about just a little bit over 1,100 acres, 197 buildings and growing, with about 13 million gross square feet is all in totality. And then some other figures that you might be interested in, we have about a 34% reduction in our carbon footprint over the years. And we're a small community, a small little town. And we, house just shy of 5,500 faculty and staff and over 30,000 undergraduate students. And then, no presentation will be complete without a little selling of the sizzle about us, and a little chance for us to do a little bit bragging. But these are some of the accomplishments that the University at Buffalo has been able to make over the last few years. So, very high on our climate action as well as our health and well-being rankings, and we've been seeing our research expenditures kind of greatly increase over the last 3 years as well. So with that, I'll turn it over to Ryan to specifically talk about our climate action plan.
Great, thanks, Tonga. So again, kind of thinking about this how frame, this is really I guess while Jay's got his kind of that fishbone diagram that lays out our process, this is kind of the equivalent in our climate strategy world. 10 different initiatives over the course of 10 years. Tonga and I had the strategic vision of launching this 2 weeks into COVID, which of course we did not plan for. But it's actually, we had a climate action plan here at the university, and it was very robust, 600 pages long, classic academic document, and it got a lot of dust sitting up on the shelf. And so when we went back to kind of Climate 2.0, our overriding principle was, how do we make this digestible and actionable for people? So 10 different areas, and then 3 integrators that really run throughout those 10. Jay, if you want to just click on that, that should come up. There we go. And then I'll just kind of walk you very, very high level through each of these in terms of what their objective is. The first one, of course, is thinking about renewables, and we've given these kind of catchy little titles. That in terms of just making sure that electric supply is clean. The one that we're talking about today and the one that keeps us up at night is really the electrification here. And Tonga is the captain of that working group. Each of these has a working group of around a dozen different people that are working across the university, student, staff, faculty, et cetera. The next one is building a localized offset program that's run out of the provost office. And then following that is really the money component, which is how do we price carbon here at the university, and also how do we budget for it? So a lot of this work costs a lot of money, and at the very end, we'll get into a little bit of how do we assume paying and financing some of this. And then decarbonizing our endowment, which is a job Stacy Napper, the CEO of the foundation, does. Decarbonizing our food system. A lot of people don't realize that really 25% of the average, at least Americans' diet, I'm sure it's probably very similar in Canada, is their carbon footprint, right? That food source. And then our zero waste and circularity work, which is run by our director of procurement. Zero carbon mobility, and that is really about phasing and electrifying the vehicle and phasing out emissions there. Our next one is the behavior change. Messy, silly humans. How do we get them to do what we want them to do? And so we, of course, assign that to our director of HR. And then finally, how do we make a better widget? the technology side of things, whether they be HVAC systems or many other factors there, and how do we think about those? And then those three that make up our integrators that we added in, resilience, justice, of course, and then leveraging the academy. So how do we do, there was a great comment in about some having students do some analytical work with data. This is that, right? How do we leverage the living learning laboratory that is the university, and also how do we think about our faculty's research in this space? So that's our broader climate action strategy. I just wanted to kind of provide that foundation for you all so that you know where that one piece in the upper right fits, right? So we're diving into that thermal, of course, in this conversation, but it's part of a larger strategy. Jay?
As we started to kind of dig into the energy projects, I'm going to start here with the University of Buffalo South campus. We like to look at energy usage through three fundamental lenses. The first is going to be the actual energy usage itself. So looking at energy in terms of energy. The next is energy cost and how to, not all energy is priced the same. So what is it that we're paying for? And then finally, also not energy is created equal, and the emissions associated with different energy systems. What you're going to notice here is that from these, natural gas is our largest energy usage for the South Campus and our largest emissions user, but it's not our largest cost. And you'll find this often for most cases, where electricity actually has a much higher energy cost. And I've come from the world of energy projects for my entire career. And oftentimes when you go out and you try to do an energy focused project, ironically, we're actually focused on energy cost. We're looking for return on investment based projects. And so if we're seeking to just simply go down the pathway of optimizing energy costs, the types of projects that we're going to focus on are going to be different than those projects that we're looking to actually transition away from fossil fuels. So I highlight that as, in my opinion, as a very important setting the goal and setting the direction takeaway, because that slight change between prioritizing energy usage and carbon reductions, or specifically Scope 1 carbon reductions, results in a much different project framework than prioritizing energy costs when you're setting the objectives to go out and do a project. And also, not all systems are the same. As I say that as well, we look here at the difference between UB's North Campus and South Campus. The North Campus was predominantly an electric resistance-based heating system. So you'll see the amount of electrical usage on the North Campus significantly different than the South Campus because it was designed differently during the 60s and 70s. Subsequently, a significant amount of energy costs sitting there associated with that electrical usage. That being said, a ton of opportunity here for us not only to update these facilities and reduce that fossil fuel emissions that are still there, but also try to manage those costs as well. So getting back to that whole strategy that we talked about earlier, the strategic plan, energy efficiency, highlighting this is what the system they've been doing, right? Over years, they've been looking to reduce load, change usage patterns, increase equipment efficiency. I highlight this for a second because there are only three ways you can actually improve energy conservation or energy efficiency. It's one of those three. If you can apply that strategy to lighting, building envelope, HVAC, the most complex HVAC systems, if you want to conserve energy, it is through one of those three fundamental pathways. As we look a little bit further here to energy recovery, I'll give a project example here at UB. This is a project concept for an energy recovery project at the pharmacy building. And this is going a little bit more into the technical weeds here, but fundamentally the idea is we have this big lab building that we're exhausting 70, 75 degree air when it's 0 degrees outside. What do you say we stop doing that? And let's take all that energy that we're exhausting, let's take that back into the building and use it to bring in the 0 degree outdoor air that we have to use to ventilate the labs. That's what this project was intended to do. Another great opportunity for heat recovery is where you find opportunities for simultaneous heating and cooling loads. many college campuses, many institutions that you have may find themselves with a load profile that looks similar to what I have here, where you have hot water being used all the way throughout the year, including the summertime. How do you know hot water is being used or heating is being used in the summertime? Well, if you ever heard the term dehumidification. Some of the areas of Canada are going to have higher dehumidification loads in the summertime. If you have labs or areas of collections, you are using energy in the hot water energy in the summertime to help dehumidify. In the opposite is you look at cooling, you may be actually using cooling for inside spaces, data centers, things like that in the middle of winter. That could be an opportunity to recover as well. And so what we look for are heat recovery heat pumps that can be implemented that actually straddle that simultaneous heating and cooling line and can be implemented inside a building or group of buildings to help recover energy from one system to the other. So to give an example, is actually outside the University of Buffalo of a completed project. This is a project for a public university. And as part of this project, we actually built and installed 1,000 tons worth of heat recovery heat pumps, is specifically in a location where we would intercept hot water on one side and chilled water on the other side. And it was serving a large athletic facility complex that had year-round simultaneous heating and cooling. And I share this because this highlights the possibilities of the application of this technology. What I'm showing you here is that these heat pumps were installed. They're providing chilled water that your facility department would love, and they're providing hot water at the exact same time that your facility departments will love. And all the way it's doing it is just transferring the energy from that chilled water side. Remember I talked about heat pumps before transfer energy? They don't generate it. So it's transferring energy from that chilled water side, absorbing that energy from the chilled water, creating more chilled water, and putting it over to the hot water side, rejecting that heat, offsetting the use of steam boilers. In fact, this is the actual steam meter that served this area of campus. We had normal operation for a period of time. We brought the heat pumps online. We had to reset the meter because we dropped the flow so much the meter actually wouldn't read it anymore. And then we kind of had made some adjustments and had to do some commissioning work. Finally, brought the system in full normal operation, and we reduced in the summertime the steam usage on this section of campus by 75%. So a 75% reduction in Scope 1 fossil fuel emissions just by putting in a heat pump that could transfer energy between those two loops. That's the power of that energy recovery aspect. Next one on here is alternative transportation. Again, many of you are probably exploring this as well. The University of Buffalo is doing a great job of starting to implement not only for commuters and students, but also for fleet vehicles themselves. Ryan, if you wouldn't mind, maybe you could speak to this slide for a second.
Sure. Yeah, so really our policy right now at the university is that every new vehicle that is purchased needs to be electrified. There are, of course, exceptions to that. Like you all, we are not aware of a affordable electric snowplow at this point. We deal with a lot of snow here in this neck of the woods. Although, fun little fact, in Scotland right now, they call them gritters, and there's a fleet of snowplows up there that are hydrogen supplied and performing very, very well in those conditions. As you can see on this graph, this is, as Jay indicated, we're kind of doing two sides, both the Scope 3 emissions that are coming in from our commuters, and we have a lot of them. So we have, roughly a community of 40,000, and only about 9,000 of those are here on campus as well. So those emissions are part of our footprint, and we're doing a lot of things from active mobility to mass transit, but really electrifying the vehicle is the key piece, and trying to provide avenues for people to make it easier for them to go electric and have less anxiety over that charging. So what you see over here is just really over the course of the year. And you can see a little bit of the flow of that at different points, the summer being a little bit less. This was really our first year, so we don't have an amazing amazing amount of data yet, but it's giving us some of that key information. And then that green line is measuring the overall the overall energy supply and aggregate that we're utilizing for that. So every amount of electricity that we're using from 100% renewable sources here is, of course, helping lower our overall emissions in this area. We just finished. I think Jay's got a slide of it there. Two things here. One, that last slide, 50% of our bus fleet right now is in assembly, will be electrified. We just worked on a big process on that. We move, I think, around 16,000 people around daily. So we're really looking forward to that. And we didn't go all in. Again, we've been having, we need to make sure that that electric works in our climate. So about 50% right now, we feel comfortable with that risk tolerance. And then in addition, on our fleet side, as Jay indicated, all of those new vehicles that are coming in need a place to charge. I think, Tonga, I think it was yesterday that the first full fleet lot, electric fleet lot, was commissioned. And so I don't have a picture of that up, but it's a bit whiter now than it was in these pictures when they had good weather to put that in. So we'll have the ability to charge 52 vehicles at the same time on this first lot, as well as 4 or 6 via DC fast charge. So this is just kind of one little tangent that fits in, but it's exemplifying that clean energy kind of fishbone diagram that Jay's laid out.
That's awesome. Then as we kind of keep progressing forward here, we talk about removing steam from different end uses. Right now, we're working through the university as part of that master plan, and what we've done is we've identified those different devices that we call our electrification constraints. The different devices that are actually embedded in the university that aren't as easy to just electrify or change over to hot water, right? These may be autoclaves, these may be humidifiers, they may be different devices like that create a constraint. And doesn't mean it's the end of the game, it just means we may have to take a slightly different approach. So again, I invite all of you as you're going through and assessing different technologies, make sure to understand humidification, things like domestic hot water, process heating equipment, sterilization are all key things that can become constraints for those types of systems. As we then start looking at thermal energy, this is kind of the part, as Ryan kind of alluded to earlier, right? Like when you think about decarbonization master plan, this is the part you think of. All those other things kind of before and after and all the different tangentials are super important because they influence the thermal energy aspect of it, and thermal energy is influenced by them. And so we're talking a little bit about how we put together the strategy for South Campus. South Campus had an existing system at UB. It was an existing centralized steam plant. And I would say it's kind of a partially decentralized, partially centralized cooling system. There are some buildings that had independent cooling systems. There's others that were kind of two central plants tied together that actually have a cooling distribution system. The way energy flows on South Campus, we basically purchase electricity and natural gas. Most of the natural gas goes right to our steam plant, and that steam plant then distributes that energy to the different buildings on campus. Most of the electricity actually comes on and goes right to the campus. However, that electricity is also used by these various chiller plants throughout campus to actually produce chilled water to cool the campus in the summertime. What we looked at doing was establishing different phases of projects that can be implemented over time. This first phase of the project actually is installing 2 different heat pump buildings, or heat pump clusters, if I should say, that basically will leverage a geothermal well field near those heat pumps, and then will serve not only that building, but a cluster of buildings around them. As I say this wasn't actually the original iteration of the plan. Remember I talked about the adaptability that you should be looking for in your master planning? We actually started completely the opposite side of campus, but then policies, or not policies, but more funding became available for projects in these different buildings. And these projects, as they started undergoing major renovations, the opportunity to move these projects up in the timeline became apparent. And so the idea was create enough flexibility in the plan where we could change the order of operations and actually take advantage of parallel projects that were happening. As we look forward, we're kind of going back to our original strategy of now we're looking across the other side of campus and putting in another heat pump building and a heat pump cluster around that group of buildings. We're then moving more in towards the center of campus and converting the chiller plants in this area and these mega structures into heat pump plants that would then serve those mega structures. And then finally interconnecting all of these various heat pump plants that are going to be located around the campus into one common network and connecting that to various geothermal well field systems. And then ultimately converting the existing steam plant into a low temperature hot water system that can back up the heat pumps throughout campus. So one question you may have is, why did you do all these little small plants? Why didn't you just do one large central one? And it's for two fundamental reasons. One, we have to maintain operation of the campus. We can't just close the campus down for a couple of years during construction. And so because of that, it made more sense to actually do these things in clusters. By doing these projects in clusters also allows a timeline to happen where not everything has to be done, all the capital has to be expended up front. It can actually be done over time and over a series of projects over several years. As I said, kind of by doing it that way, allowed enough flexibility where the UB was able to take the opportunity to incorporate these heat pump clusters, these heat pump plants into major renovation projects so that it better aligned the energy master plan with the campus plan. Ultimately, the objective here is to start converting that energy entire profile, right? You saw that big natural gas line from earlier coming in. Ultimately, when we're done on this campus, it'll be primarily coming from an electric utility. We'll be able to absorb and reject energy from our geothermal well field, but we're still going to leverage those condensing hot water boiler systems to back up the system should there be a failure. As you look at that and you see that natural gas line, going to a condensing hot water boiler system, we actually also have looked at in the future as hydrogen, getting back to the discussion we had at the beginning of the presentation, becomes more viable. Hydrogen could be an option that either supplement or act as a backup to the heat pump system once it becomes more market viable. So we're looking ahead to being able to accept that potentially emerging technology in the next 10 to 15 years. Switching gears to kind of the work that we're doing at North Campus. Again, different type of flavor of a project. Here in North Campus, we looked again at our heating and cooling loads. You keep hearing me come back to plotting these loads, understanding how energy is being used. And what was important for us to understand here was how much of this was actually associated with fossil fuels and how much was actually associated with electric heating. This was an important graph here in black. You're seeing the fossil fuel energy usage of the thermal profile. That really helped tell us what that usage profile was and zero in on those aspects of it. We further looked and broke down that into, well, how much of that fossil fuels is necessary for process, for sterilization, for clean steam generators, for autoclaves that are kind of hidden throughout the campus. So we're able to break that down further and identify those electrification constraints. Ultimately, we were able to come up with a loading profile that we could work with that would establish essentially what the thermal-based heating and cooling load profile was and break it down to what that fossil fuel usage was for a heating load. I just want to highlight that there's a lot of exercise and math in there. Understanding where your heating is actually coming from the terminal load, kind of working from the ground up, is an incredibly important exercise in order to come up with a very actionable plan. So here, as we started laying out different options, we started looking at different heat pump plant here, more centralized. This has a central chilled water system that we could actually leverage a central chilled water plant, convert it to a heat pump, and then put geothermal well fields around that heat pump. We would then be able to send and control the thermal network through this chilled water loop around campus. As we did this, we kind of took some early on analysis and identified that what's amazing, while the campus is so much larger, because there's so much electric resistance heating, we actually weren't going to need as many wells as we needed on South Campus. So our thermal load on North Campus was actually much less, which means we don't need as many wells. So that was actually kind of a pretty cool understanding that came out of this process. But then an opportunity came up, an opportunity to actually leverage a new data center that's being built on North Campus. And there's a potential, or the North Campus is planning right now to actually accept a 15 to 20 megawatt AI data center that's going to be used for research purposes. And as many of you know, data centers put out a lot of heat. It's kind of a big, not only they consume a lot of energy, they put out a lot of heat. And as an energy engineer, I like to look at data centers as really essentially electric boilers that do something else. And so taking that opportunity and that approach, we reevaluated our plan and looked at, well, what if we actually leverage all the heat from that data center as opposed to actually putting in geothermal heat pumps? And what we found is we could leverage and provide most of the thermal energy for the entire campus by recovering energy from that data center and leveraging heat pumps to transfer that energy to the buildings, and that we would only need roughly 200 wells to actually fill in any gaps in that process. So just highlighting here the importance of kind of that collaboration between facility planning and energy planning, and really looking for those opportunities to leverage data centers. What a great, great way to address some of these loads. And finally, it's not just about current day, it's also looking into the future. This is not only an active campus, it's a very growing campus. And so we have to also project forward what our future heating and cooling loads are going to be. And so working with campus leadership, we're able to start to assess, all right, what are our plans over the next 10 years for buildings? We put together rough thermal models to start assessing what those changes are, as well as changes to future cooling loads, not just for added buildings, but for new buildings that we're looking to come online. And as we did that, we started to observe potential challenges with that. One of the key challenges being at some point they were going to exceed the cooling capacity of the chiller plant on North Campus. And so while they could bring in a couple projects over time, as we kept going down that pathway, that business as usual, not only were they going to continue to run into carbon issues, if they followed that business as usual pathway, they were going to run into capacity issues, creating an opportunity to further enhance this project with long-term master planning for other additional plants. And that's kind of where this additional heat pump plant option came in. So still have this expansion of this existing plant here to serve the heat pump of the existing facilities. We have Empire AI, which is our data center that's going to be serving and providing energy to this heat pump plant. Energy is going to be transmitted, leveraging the existing infrastructure to all different buildings that'll have some heat pump clusters throughout this core campus area. At some point, we're going to need additional heat pumps and heat pump plants to serve major renovations in athletics and new buildings that are going to come up planned north here, as well as over in this area on to the west side of campus. And so we identified new heat pump plants that will go in those areas that would provide the additional cooling capacity necessary. So we kind of laid out a strategy. This is a timeline. It's kind of still in draft right now, but it's a timeline of basically saying, hey, you guys have one more building that you can get on your network right now without having to make any major changes. At that point, we're going to need to start expanding this chilled water plant. We're going to put in localized heat pump clusters that are going to feed off the chilled water plant and still kind of absorb and reject energy relative to utilizing the existing chilled water network. At some point, we're going to get to a flow constraint where we can no longer use that piping, and we're going to then have to build new geothermal heat pump plants to serve major renovations that are anticipated, that are planning out 10 to 15 years from now for these areas. So we're looking 10 to 15 years out and planning infrastructure that are going to leverage all the technology we can use, leverage decarbonization technology, leverage the AI data center, leverage geothermal, and be able to plan and address heating and cooling needs for these major infrastructure projects that are going to happen, a long ways out. And then finally, kind of looking back and looking at this load balance, this is just another great visualization here that shows how through the use of heat recovery from the data center, we are able to address now, even with the future heating loads of the campus, Still, the majority of campus were able to basically heat based on the rejected energy from that data center, with only a small incremental portion of it needing to come from a geothermal energy source. All that stuff, it sounds great. You know, how does this energy come to us? Renewable energy. Solar is something that the university has invested in. This is a signature solar array that was designed right on North Campus here that helps provide that energy. We have different arrays across campus that have been providing solar energy to the site, as well as renewable energy purchases over time. The next part here is looking at our utility capacity. And I'm going to bring us back to a story for South Campus again. At some point, we hit a crossroads where we were looking at going electric resistance heating versus heat pumps. You guys remember back to kind of the setting the table part that I did where we talked about heat pumps? We talked about, hey, if you do your electric boiler, it's going to be pretty much 1-for-1. Heat pumps are going to be 3 to 4 times less energy input than electric boilers. We did evaluate that as an option. I showed this picture of what we would have to build at South Campus, and Tonga pretty much put the stop to that at this picture. But the fundamental aspect was this is an hour-by-hour profile of the electrical energy usage on South Campus. The item in blue here is how they're currently using electricity. This is an hour-by-hour model showing how much electricity they would use if they used heat pumps. And then this red is if they used electric boilers. And what you're seeing from this is that not only would it exceed the electrical capacity of the system, it would exceed the electrical capacity of the grid. Finally, many of you may be asking, well, what about redundancy and resiliency? You know, if I have everything on electric, what's going to happen with my redundancy and resiliency? Basically, the idea here is that under normal operation, we would operate as a heat pump. When we had a loss of power, we would leverage condensing natural gas boilers to back up the system. And then as a result, those natural gas boilers would be able to heat and provide energy to the system without the use of electricity. Long term, we're looking at transitioning those to the fuel cells. And then ultimately incorporating that technology into more training for operation and maintenance staffs, be able to accept emerging technologies, and ultimately get to a carbon neutral system. And with that, I'll turn this over here to Tonga.
Great. We're going to take just a very quick break, about 3-4 minutes, if that works for people. Just give you a little kind of stretch, et cetera, bio break. And why don't we pick it up at 1:18, 1:19, if people can do that. Thank you. Gotten through. So we've really gotten through, I think, the bulk of the content and some of the technical parts of the Clean Energy Master Plan and how we're approaching it. Now we're going to kind of migrate into how do we actually do this? The stuff that lots of times isn't written down in the nice manual or the report, but how you merge this in with both the organizational behavior you have and the structure and processes of how you move things through the university, both senior leadership, your own facilities teams, et cetera. And Tonga's going to help us tell that story.
Okay, thank you so much for the entry point there, Ryan. So if we can go to the next slide, please. Thank you, Jason. And I think, those of us that have been in the world of facilities management at the very least, kind of been feeling the pinch point about, organizational change management, right? I kind of saw in some of the chats about, some reluctancy, especially on the facilities management side, about adopting new technology, et cetera. So for me, this picture kind of says it all, right? Culture definitely eats strategy all day long. The best report, the best technical designs, anything else can go to the wasteland very, very quickly if you don't kind of factor in, the cultural side and, the engagement and buy-in. And I think before we kind of get started, I think the other big thing that I just want to share, and I know when we kind of put this out there, everybody's like, oh, wow, like this in your mindset, it might be this happened so quickly. And I just want to say it really did not. It's been a very long journey. And the other thing that I'm kind of wanting to show with this timeline is to not be afraid that this is iterative, right? Some things might change and we changed. What Ryan and I kind of put out together in 2018. Originally, Ryan alluded to that in 2009, the first climate action plan for the University at Buffalo was implemented or was put out there to rest in peace on somebody's bookcase. In 2018, Ryan and I partnered up, and I think that is the key. And I know there's a lot of multiple constituents here from the sustainability office world as well as from facilities management. If there's one thing that I think Ryan and I will both agree on is that partnership is absolutely critical, right? Neither side of the house is able to do a lot of this work unless there is that partnership and that integration of the two offices working together collaboratively, hand in hand. And I think that's what we found. And it came out in 2018, nicknamed IceCap, and it was our joint venture to kind of merge, the energy conservation or energy management plan that I wanted with Ryan's climate action plan. And there's actually a second end to this joke is that I am actually a Canadian, transplanted from Toronto down to here. And so we kind of did the ice cap also in just to my hometown as well. And then, we transferred from that into 2020, where we started just calling it the 10 in 10. And that was version 1. 3 years later, we changed that very 10 in 10 a second time into our version 2. So again, don't be afraid of this not ongoing evolution that's been happening. Yes, and thank you for the shout out. Born and raised in Port Credit there. So good times. Next slide, please. And this is just a visual, right? You kind of saw this was actually the original. Next slide. And then we removed some things. We, collapsed and condensed some things and added what we call 3 new icons, looking at, efficiency, behavioral, and responsible investing. And then added the integrators that Ryan kind of talked about earlier. So, when we kind of got started in this whole journey, when we kind of, secured the services of WENDEL, of Jay's team, and we started diving into the working sessions and straight out, all 3 of us agreed that we really needed the complete buy-in from day one. So before WENDEL got any concept of doing anything, of even trying to formulate any ideas, we had these sessions, and they were gracious enough to allow us to come off campus. And I think that was another big thing, kind of removing everybody from their territorial kind of feel of where they have this comfort zone, taking everybody away. We met up at the WENDEL offices where you see everybody here. And it was made up, I brought all of my directors with me, right? I had the operations director, EH&S, finance, campus planning, capital planning, director of design and construction, et cetera. We had a few of our senior level trades supervisors as well coming along to witness and actively participate. And then you kind of see Ryan there in the bottom left as well. So our chief sustainability officer was kind of hand in hand in this whole time. And what we kind of showed was just that this is a partnership. We wanted to make sure that this plan kind of showed the growth that we were looking to have on the campus, as well as what we are currently trying to do today, as well as all of the policies and executive orders and everything else that we had to deal with at the state level for our funding. So I think that session was great. The other thing that really helped us too, and this is something you will have to do for yourself, but our mantra here within university facilities at UB is one and done. Very similar to you all, publicly funded institution. We get our monies predominantly from the state. And so we kind of have to make that money stretch. And so the one thing that I kept instilling in my staff was this concept of one and done. Meaning we don't want to double back, right? So whatever work that we're doing in a building, we take care of all facet of it, and we need to look at that full scope. And something might be lower on the critical maintenance, but if it got funded early days, we go through and we have to look at all of our deferred maintenance issues around that surrounding area, try to incorporate it all so that we're getting all that work kind of done reset that deferred maintenance clock and kind of move on. Next slide, please. And so our strategy, the things that we preach was that the cost of doing nothing is not $0. So putting your head into the sand does have a price tag to it as well. And more often than not, it's going to be double, if not triple, what you didn't do in terms of, ongoing repair and maintenance and renewal of it. I know probably a lot of you don't have the same problem I have about this pesky thing called deferred maintenance. But, for us at the University of Buffalo, we're just kind of nearing about the $650 million of deferred maintenance of our backlog entities. So I just want to share that because, again, living that very same world and reality that you all are living, and to, just play the fiddle a little bit more. So I get funded about $19 to $20 million per year to handle deferred maintenance. So I'll kind of let you do that straight line calculation right there for yourself. So for us, getting the funding and how do we strategically align ourselves, up with those plans was really huge for us. And I knew that, we had to leverage the fact that a lot of our facility as well as infrastructure and equipment were nearing its end of life. And then always kind of looking at that capital or CapEx versus OpEx. A lot of times systems kind of get put in, maybe at the upfront CapEx is a little bit, less costly. But when you look in its totality of its lifespan, when we look at the life cycle or total cost of ownership, it is significantly more. So never taking our eyes off of both of those worlds when we do any renewal projects on the campus. And then lastly, making sure that you always include in, we have a facilities master plan. So it's our roadmap of what we're doing in the next, 5 years, 10 years, 15 years, making sure that you align that as well as a clean energy master plan if you have one. So this is just a journey, a day in my life, if you will, or a day in my 10 years here, just kind of walking you through. So when I got on campus, the one thing that I knew I had to do was, win friends and influence people, right? Being a public institution, it's very hard. We have an entity called the State University Construction Fund, where all of our finances kind of run through them and come to us. They also have another portion of the money there that's called lump funding, and that's where the vast majority of the major capital renewal funds are in that. And it's almost like a competition. They have criterias. All the campuses under the State University of New York kind of put in their almost like a proposal or applications. And then, it gets kind of like awarded based on the points that you kind of hit against those criterias that the SUCF team has kind of laid out. So I knew this was key. So what I ended up doing was my team and I, we pulled together and we were looking at, okay, what does this mean for us? So how do we tell this story to SUCF? And it had to be wholesome, right? It couldn't just be, well, I got a tree growing out of my roof on this ever building. That wasn't going to state the whole case for us to be able to do everything out of that one and done. So we kind of said this is UB's like major priorities, right? And this came from our president. We need to increase our research expenditures. Student success and experience on the campus is paramount for us too. And like anybody else, we need to ensure that our student enrollment is at least constant, if not growing every year, ideally. But that being said, that's the easy part. There's so many interdependencies, right? So on the right, we have these 3 criterias that we have to work against, our flagship top 25 ambitions. We have our state legislation and climate action kind of mandates or priorities. And then we also have restrictions ourselves with National Grid. I know some of you in some of the provinces are probably feeling the same that we have down here in New York State. But then on the right side, we're looking at the reality, the day-to-day life on the campus. We have capacity constraints, we have renewal constraints. There's always resiliency issues going on as we're getting kind of hit with more and more of these drastic, weather events that we're seeing on campus. For us, we've been growing and we continue to do so. Over the last 4 years, we've added over 450 new hires of faculty and staff. But at the same time, we are a unionized campus. And so, I've also had extremely outdated and obsolete job descriptions that I've had to use in order to recruit my skilled trades, which is also kind of dwindling in numbers that we're seeing in both countries. And then, with campuses built 100 years ago and 50 years ago, respectively, we have a space shortage, but more importantly, the space that we do have isn't functionally appropriate. So the space that we had and built back in the 70s, say here for North Campus, is just not indicative of the way that we teach, the way our students want to learn, and more importantly, what our researchers need today in order to fulfill their research requirements. Next slide. And then, so what we kind of did next was kind of start looking at these projected hiring. So we started working with our budget office as well as our provostial office to kind of start pulling together, all of the decanal units kind of hiring projections in every upcoming fiscal year. So this was the one snapshot that we kind of took where, there's many investments of how people were using to bring on new research faculty as well as staff. So we started kind of layering these pictures, right? And again, these are just funding that they're asked for. It's a lot of decanal units had reserve funds, and so they were using that in order to bring on new faculty hire. Next slide. We also kind of looked at, benchmarking kind of like space requirements, right? So again, looking at all the various disciplines that kind of make up our schools and decanal units, the type of space that they would need in terms of labs, national standards, et cetera, and just kind of plotted this overarching kind of look at how much space is truly needed on our campus. And what it showed was that we were definitely at a deficit, at least on the research side. So this is just in a totality there. We also did the same thing for the students, right? As I mentioned, top two of those main priorities for us were student-centric. And the same thing, we did a lot of benchmarking nationally against our peer institutions as well as aspirant institutions that we had. So you'll see a lot of UCs on there. And we were looking at, what was their net assignable square foot per students that made up. So these are things like learning landscapes, classroom sizes, libraries, seats in the libraries, et cetera. So we start plotting that course against, our student growth projections as well as our current student body. And then also, working with our registrar, we kind of looked at the classroom space too, because also that we felt the crunch there as well. And just kind of doing a lot of these assessments, kind of baselining, benchmarking against others. Where are we currently? But more importantly, how are we against that national levels? So we kind of pulled all of these avenues together. Once we got all of that, now it's that mirroring world, right? When I'm kind of saying before, and I'll say this again, is like, I truly believe if you want to start implementing a lot of these clean energy or sustainability type initiatives, deferred maintenance is our best friend right now. And because you can kind of layer on all of these kind of things. On the previous slide, it was a lot about buildings, right? For us, those were all actual buildings or halls that we're looking to renovate or do gut rehabs on. But next slide. But do not forget about the underground, the buried stuff, all the utilities, the infrastructure, the chilled water lines, supply, return, electrical lines, breakers, transformers, everything else. And that's what we kind of start building out in this slide to kind of work with SUCF. And if all else fails, if nobody believes your numbers, a picture is worth 1,000 words. And we started taking a lot of pictures to kind of start demonstrating just the level of deterioration that we're kind of seeing on the campus as well. Thanks. So what does this all result in? So just a quick pictorial timeframes here. So this is the North Campus. So in 2011 was when we did our first facilities master plan. And we had a little bit of trickle of funding from that SUCF group that I kind of made mention. Actually HOTC there, which is Heart of the Campus is the acronym. We self-funded that. So really the projects that got funded from the state was that Davis Hall, which is a brand new engineering building construction, and a fifth floor renovation of Cook Hochstetter, which was a research tower. And the fifth floor was specifically for our chemistry department. So that was what we got funded for. So both HOTC, self-funded by the campus, and we got 2 projects. But then when we started building that, collaborative, holistic kind of piece together that kind of brought in all of those entities and layered on the Clean Energy Master Plan, as well as our deferred maintenance, our growth, whether it's from faculty, staff, students, everybody else, and the level that our campus is at, we started seeing an uptick. So that bulldozer is where we are today. So we are building a new engineering and applied science building. Construction will start this summer in June. We've also got funding to build a science education center. So that's our first and second year labs, chemistry, biology, physics, geology. So to fit it out to become a lab. We got funded for a brand new AI society as well as interdisciplinary research building. And as well, we also got full funding for Lockwood Library, which is also a complete gut renovation of that infrastructure as well. So in a very short time frame on North Campus, we were able to secure quite a bit of funding from LUMP to demonstrate that. And we will also leverage some of these things into infrastructure renewal as well with the state money. Next slide. And on South Campus, it was very similar, right? When you kind of look, we got that funding in 2015 from SUCF with building Hayes Hall, which was for our School of Architecture and Planning. Small projects we've self-funded here to just, again, those lean years, trying to make sure that, we were doing some renewal projects for our students on campus. And then it was kind of like that turn on around, Townsend BRB area, where we kind of got that big dosage of capital kind of injection into us, where we were able to do Townsend Hall, which was a derelict building, completely unoccupied. We did a gut renovation with that one, turned it into our home for our HR department. BRB is another massive research tower on the South Campus that houses our School of Dental Medicine. Crosby Hall, another gut renovation. And the beauty about Crosby and Foster, it was our first dip in to the proverbial heat pump era. These are water cooled and they're coming online as well. Foster, we will be moving the Graduate School of Education into that kind of in the fall of this year. And then we got funding to do our health sciences backfill, which is 5 buildings that kind of make up a little donut, a little octagon, if you will, as well as Clark Hall, which is another complete gut renovation for our rec and wellness, and Parker Hall. And Parker and Clark will be our first geothermal heat pumps, installations on the South Campus. So it worked out well for us, right? And I think it was back to that storytelling and to be able to kind of layer in all of those things, right? And when I say about deferred maintenance is because a lot of these buildings were gut renovation, we were able to kind of put in all of these wants that we have. Having executive order from our governor down here also helps to push that needle. So I would say utilize every lever that you can. But I think it really does start with kind of building that story that brings in all of those key components that are critical for your campus and what are you hearing or kind of like the touch points that your president and your provost and your VPFA are looking to accomplish.
Thanks so much, Tonga. And Allison, great question. Tonga just touched on both Foster and Crosby being 2 of kind of our exemplified kind of projects that are built to depending on how you want to count net zero. So for scope 1 and 2, yes, those ones and everything else after that we're building. The regulatory framework is helping with us because that is pushing in that direction, but we're also adding in, we've got a more aggressive climate neutrality goal than the state. So yes, everything we build now, I would say meets that definition. There's a little bit of detail on that definition in some, depending on how you're counting, but yes, the spirit of it. And now I just want to kind of bring us home here. Congratulations, you've almost made it through 2 hours of us talking at you. Kind of tee up those questions. I'm going to truncate my version of this or make it very quick here. But I do want to just provide you a little bit of framework on how the heck are we going to afford this, right? How are we actually going to fund this? The short answer is we don't know, but we took a crack at it. And we are working to really try to think about how we do that over the long term. Many of you may know, especially the sustainability coordinators on this call, there's an organization called Second Nature, which is kind of the higher ed climate change group for North America. They do amazing work. We leveraged an opportunity that they had out there for pro bono services from Brailsford and Dunleavy, kind of leading firm in the decarbonization space. These are some of the clients that they've worked with. And unfortunately for Beth and Beth Corey, our university controller in Tonga, it's kind of how I spent my summer. We worked with them to really develop the business plan. So the next slide shows really kind of, something that all of you have, your scope 1, 2, and 3 emissions. The work that we were doing on decarbonization really excluded scope 3 emissions. We're working on those here at the university, but they are kind of a separate beast, if you will, and involve a lot of different factors. And we're really, in this exercise, trying to focus in on scope 1, those direct emissions on campus, and scope 2, purchased electricity. So, which is really the heart of what decarbonization is. Decarbonization being that more granular term of what you can do directly on your campuses to reduce your footprint versus climate neutrality, that kind of more umbrella term that would include offsets and things of that nature, as well as some of the scope 3 emission strategies. And so from the next slide, you can see we took our UBs 10 and 10 and kind of dropped out a few of them to focus in on that specific decarbonization strategy. And then in the following slide, you'll see we just rearranged some of those original 10. That's what we're talking about still, but we put them in a little bit of a different framework here and phased in the work across clean energy, efficiency, mobility, and then, of course, stuff or materials. And that really framed out for us, as well as 3 kind of phases within each of those, how the work was starting to align and the kind of temporal context of that. The next slide shows at a very macro phase of, and a visual phase of how we're going to get there. So if you look at, maybe Jay, if you might be able to put your cursor right where the shade is, where that line kind of comes in, thank you. That is where we are today. And this graph is a little bit confusing because it looks like we blow up and our footprint goes up. What I'm trying to show you is all of our emissions, right? So you'll see in the red there, that is our renewables. Right now, we've got that down pretty much, or at least our emissions from scope 2 down to 0. But I'm just showing you, re-showing those there as well. So the blue is our efficiency mechanisms that are coming into place, which really are part of some of our, as Jay explained, part of our electrification work. 100% renewables, which we're at now. And then you can see in that pink area, that's everything we just talked about. So that is the work for scope 1 and 2 emissions and getting us down to 0. And then you'll see that light gray, that is some of our mobility, our fleet, things of that nature. And then that dark gray is, we have no idea. We don't know how we're going to get rid of that at this point, probably through offsets, but we're going to continue our work in that. And then finally, really the last few slides here are kind of the money, both figuratively and literally. And what this chart shows, I'm going to give you this in a visual in just a second, but it really takes the overall cost, right, of what it looks like to decarbonize. It gives you the cumulative of that, and then we kind of back it out into net present value in today's dollars. So you can see this better in this slide that Jay just popped up here, which is on the left-hand column. That is business as usual. Over the next 20, 25 years, that would be the cost of what it would, of what we will incur if we just kind of trot along on our same path. Our pitch is, don't do that. That would be a mistake for all the reasons that we've talked about. And here's the beauty, that the numbers show right now that if we do that in a slightly different way, in terms of funding and fronting capital, it will actually cost slightly below what the business as usual model produced. And yes, that does include capital, that does include commodities, that does include operations, and it also includes the price that New York State has set for carbon, the social cost of carbon, which is the red that you see in that model. So when you look at this over time, on the next graph, you can see, yes, we have to front more money, more capital upfront in order to realize and recognize those savings that will come in and then bring us on parity in the overall amount that we're talking about. And finally, just in recap, I'm going to Jay told you what we were going to tell you. We just told you what we told you, and I'm telling you what we told you. This is really the kind of takeaway from our experience, and what we're starting to see is that, this sector is poised and is, I think, the only sector that can play the role that we need to lead on climate. There's no better time than to do it now, not only because of the science, but because of where we are in terms of the capital infusion that needs to happen, as well as where the technology is. But it's going to require an all funds approach and a different way of thinking about how we finance things. And of course, it's an integrated and all-inclusive strategy here of thinking about CapEx in a different way, and thinking really beyond the current model, at least in our situation here at the University of Buffalo. And then finally, and perhaps most importantly, a lot of the work in Tonga did a nice job talking about this. It's lots of times I have to remind myself, it's not about selling the importance of working on climate change. It's about building 21st century facilities for today's students, and facilities for our faculty to do their research. Oh, and by the way, if we do that right, we can do it. We can incorporate those climate neutral systems that really augment that and make things happen. So we'll pause there. That was a lot of information. We really thank you for your patience, and Stephanie, again, for having us and inviting us, and be happy to take any questions. I know we had some dialogue in the chat as well, and some answers are in there, but I'm sure you have more. So we'll yield the floor.
Thank you so much. And there are a couple of questions in the chat, and I think we can jump right to those if you want to take a deal with them. The first one that I saw was from a colleague of mine here at RSC Polytech, asking about how is organizational change management integrated to create buy-in from senior leadership?
You want to take a crack, Tonga?
Yeah, please let me. I like this is the partnership that Ryan and I have. So I think two fronts on that one, and I think it's just taking it back, right? You need to kind of understand what are those prize principles that, whether your provost or your VPFA or your president has, right? And that was the fundamental switch for us, was to kind of go back and being like, you want to be a top 25 research institution, you want to increase your research expenditures, right? Those were critical for our provost. Again, you can't do that circa 1970s building, right? We're not going to do AI research. We're not going to do cutting leading edge, research into Alzheimer's disease or any of those other things. So it's kind of like linking it back to something that resonates with that person, because, to go in there and, have that visual of the turtle with a straw stuck up its nose is not going to kind of win a whole lot of people when you're trying to access funds that have multiple kind of stakeholders kind of vying for it as well. And so I think for us, that was just kind of reformatting and going back to that why all the time, right? I think that kind of helped us a lot. And I think the next question was who
Can I just
add, people? Yeah.
Can I just add one quick piece to that? I think Testament, it's a great question. I would just, from a sustainability perspective, Tonga hit the main argument that we were using. I think the aha moment for me, though, was realizing, like, it's not my job to say, hey, sustainability is the goal or climate action is the goal. Like, no joke, right? Everyone knows that. I think the point is how do you leverage climate action and sustainability as a strategy to achieve your institution's goal? And you flip that so that you're really working to help leadership solve the problem that they're focused on. But if you can frame it right, and I don't think that's just a talking point. I think we can really clearly show how doing this, and I hope that was why we focused on the why in the beginning, right? Because it is about the recruitment of new talent into the enterprise, as well as, of course, students, who pay a huge chunk of our business plan. So taking that component and really making that clear to leadership that this is a value add for your goal, that was the heart, I think, of how we were trying to make that case go. Sorry, Tonga, go ahead.
No, and then I think there was just more ask about master plan. So, when we did our facilities master plan, the first one, the comprehensive master plan, I'm relying on Ryan because I know our former dean of architecture and planning was actually fulfilling that role, right? And I believe a consultant was brought onto campus to help develop that.
Yeah, a series, a team of consultants, kind of different subs in different areas as well. Tonga, the reason Tonga can't answer that, she was at Ryerson in her role running facilities there as well and sustainability. I am blanking on the name of that, but we can certainly get that for you as well. I think what was helpful about that is it helped set the big picture vision of kind of three campuses, one university. I think what Tonga and her team have been able to do is really crystallize, okay, what does that mean and how do we do that in a decarbonized way? Because while there was language that was given to that in that capital planning, which is what I would have done, there's a big difference between language and actually the substance of what we just went over, which we did not have at that time.
Yeah, so in answer to your question, Tesla, I mean, it started there. It started with the comprehensive master plan because it laid out that overarching feel of what the three campuses would be. But over the years, we've had to pivot. We've made different moves within those plans. So I don't think there's ever like a formal handoff. Like that was our jumping point as an institution, and we've continued to move. We've done other master plans that have augment that and constantly revitalizing it. We've done, a housing master plan, innovation hub master plan, athletics, everything else, and all of those kind of, and then our own clean energy master plan kind of layers on. So it's kind of like a living document that we're always, as we do something, we take a look back. The comprehensive master plan is kind of like our DNA or our guiding principles. But things do kind of change over the course, of when that was prepared to today, right? And mainly because of funding and as well as state requirements of us as well.
And then maybe to Allison's question, and Jay, I'd love to hear your response to this as well. We never, if anyone happens to have an extra $1.3 billion lying around, let us know. But obviously, we never have enough funding for, this is expensive work. We are fundamentally remaking 13 million gross square feet on our campuses in a decarbonized way. And so what we've tried to do is to break that down again into these kind of digestible chunks. Obviously, the thermal is the huge part of this. And it will be a kind of several different pieces, but we're also really trying to push the boundaries of thinking differently and a little bit more innovative. And we just had a meeting yesterday, Jay. I don't. We probably don't have to go into the details because it won't make sense to this crowd. But like how we're thinking about those innovative buckets and your national work on this would be good for them to hear.
Yeah, I think as we dive into these projects, you can break them into three categories essentially. If you heard Tonga talk about these major projects that they're undertaking and incorporating heat pump projects into those major projects, there's a capital, the way I'll call it is almost architectural led, like, hey, we have to make this renovation. We're going to build this new building anyway. We're taking the opportunity for that project to incorporate, obviously, not only heat pumps and electrification technology into that project, but also maybe put in a plant that can serve other buildings, right? Kind of help a friend out. We found as you go through that, there's going to be other projects where we're going to have to make large central utility plant upgrades, and we're going to have to make larger distribution system changes. And we're looking at options right now to leverage more of a private-public partnership, triple P arrangement, that would be somebody that could own or manage those assets and operate those assets potentially, and take some of that funding burden off the university itself and make it more of an energy as a service delivery model for the larger scale heat pump plants and distribution systems. And then the third one, and it's, believe it or not, it's actually probably the largest nugget in here, actually gets down to the actual deferred maintenance. And the renovations inside the existing buildings that aren't being gut renovated, that aren't the new distribution system. And that's a lot of hard work that has to happen there. And there's going to be work that's got to be done there through probably the use of existing projects and existing offsets that are happening through the university, but also through, and I'm going to use the term broadly, the capitalization of deferred maintenance, leveraging energy performance contracts or some variant thereof. And what those types of projects do is they are, designed for a company to come in and pull together, several dozen smaller individual projects, put into one more comprehensive project, and they can go in and execute those projects kind of as one capital item. And it's usually more engineering-based types of projects. So kind of larger architectural-led projects for gut renovations, triple P, some sort of energy as a service model for kind of that distribution system. And then the other end of the spectrum, potentially energy performance contracts or some other sort of engineering-led type of deferred maintenance type project.
And if I can just jump into what Jay's saying, I think that's a tactic that a lot of my facilities, partners out there can maybe lean into this one. Sometimes you almost like to wedge your team that this is you can only go one way, right? And when we set the tone with the Clean Energy Master Plan, when we talk about those brand new constructions or gut renovation constructions, and we're doing those type of work in there with the heat pumps, et cetera, these other little ones in itself, it's got to feed into that overarching infrastructure and system, right? So in some ways, it's like, this is the only path, right? This is the way that we have to take when, we have to replace a valve or something kind of goes within a building that is not slated, for a major renovation work. How do we kind of align that up? So it almost is this guidebook, if you will, but it's kind of like, no other option. And it does help actually with buy-in as well.
Yeah, that's
And
great.
I would say, having water main breaks and cutting power to your, C-suite floors always helps to kind of set that tone for the dire need of DM money on the campuses. And again, that's per credit sense of sarcasm humor. So
I was just going to add in, it's coming straight down the QEW to us. Maybe just to close out, I know we are at time here, but Vonette, I love your question. We'll use it as our kind of parting shot here. A lot of stuff to learn. I guess it's probably not politically correct to say we messed up a lot, but certainly a lot of things that we learned. I think the biggest thing was that we created a plan that was, yes, incredibly robust, incredibly detailed, and it just went nowhere, right? It had no traction. And I think we sometimes specialize in this in higher ed. We have this great analysis, but we get paralysis from it because it's not actionable, as your question, kind of insinuates, right? And so when we came back to it, that was the main thing that Tonga and I really tried to look at. We also, facilities, while they were at the table, they really weren't at the table when that first plan was made. Tonga wasn't here, but also just the organization. It was parts of the university, but not the parts that actually had to do the decarbonization work. So we had a lot of leadership in it, but I think, it was detached from a little bit of the on the ground, how do you really get this done and how do you get stakeholder engagement from that? So, from my perspective, and it pains me to say this because I like to ribber as much as I possibly can, but it really, the thing that I learned was that you need a strong partnership across your kind of key team that Jay outlined in the beginning. We've done this work because we've got a really great leader in facilities. We've got, I think, a really great champion in the vice president for finance and administration. Our university controller understands this now, and that was a journey, and she personally is committed to it as well, like all of you. And then our partners from the outside. Jay isn't just at WENDEL companies. He's also an alum of this university and serves in the School of Engineering in many roles to move that institution forward. So I would say the biggest thing was we didn't quite have the team to make it actionable. And that was what we had to spend a lot of time building. And then we started getting traction. So that's my big takeaway. I'm very sorry. I know it's 2:00, so I want to yield back, Stephanie. And again, thank you and the entire team for giving us this opportunity to have this dialogue.
And thank you to all of you. We really appreciate you coming here and sharing this information. I have literally pages of notes, and I know we're going to have some great conversations at our campus. And I imagine the same for everybody else as well. So thank you so much for your time. And thank you everyone else for attending. And I look forward to continuing these conversations.
Great. Thank you, Stephanie.
Thank you.
Thank you, everybody. Really appreciate the opportunity.
Thank you.